okay. I started streaming. Let's see if it's good on Twitch.
I see that you're streaming.
So refreshingly delicious.
I got a fucking ad. Let's give it a second to run, and then we'll just do a quick check here.
You're also showing a problem on the stream as well.
Yeah.
Okay.
I know. I was just opening some random tabs. I was just getting the aspect ratio. It looks.
So it. Go on.
It looks actually after this ad finishes. Because I'm not actually logged into your account on Twitch. Okay, well, no, but it looks fine. Because I'm not actually logged into your. Yeah, audio is fine too. I think we're okay.
Okay.
Let me start the event. We'll start the event, but we'll give it a couple minutes. People usually kind of trickle in a bit here and there. Let me send you the link while I'm at it. So here's a CoderPad, Leonora. Feel free to log in, get comfortable. Have you used CoderPad before? Okay, that's good. Okay, let's see. Oh, I have so many pings in here.
Okay, I'm in. Can you see my cursor?
Yeah, I see you here. Yep, you're at the bottom there. You're good.
Oh.
You're good. Let's see. Don't need to respond there. I need to. Okay, that's fine. That's good. Cool. Let me go to. What's the announcement channel called again? Oh, you're in it right now. Are you doing it?
Yeah, I'm doing it right now.
Okay, go ahead and ping people. Nice. Okay, we'll give people a minute to trickle in. I always say that, but I usually just stay until the number hovers around somewhere around the number of respondents on the.
30?
It depends. It depends on how many responded to the. So how many? Let's say 17 people are interested. So kind of in that kind of range is what I aim for, or just when it stops going up.
Okay. Oh, one quick question. So I was wondering how many people are in the queue right now. Can I still rejoin the queue after I finish this session?
Yeah, you can definitely still rejoin the queue. I'm not gonna show the form on stream. Let me just quickly have a look. So you are Leonora. That is here, and after you, there's about 6 people. No, there's more than 6. There's 2 tomorrow. I'm not counting those 2. 1, 2, 3, 4, 5, 6. So it's about 8 people. Of the 8 people, I've scheduled 3 of them in the next weeks already, and then you'll go after that. But usually I find that so we get people in the queue, but when I reach out to them, there's probably only about a 75% response rate, which is pretty funny.
Oh, really?
So a lot of people who sign up don't respond. Just kind of like whatever, cool. So for those people, so there's 8 people, but probably 6 of them will respond. Yeah.
Okay, so should I resubmit the form again?
Yeah,
Or
so
just,
after this,
tell you?
after this, I'll remove you from the form, and then you can resubmit. I don't know if you resubmit if you're already in here, so I'll remove you later today, and then you can. Actually, remove right now. Let me see if I can delete you. How do I do this?
Okay, thanks, Leo.
Yeah.
I think I remember when you reached out to me for the first time, I actually missed your message. I don't know why. I didn't see your message. I didn't get the notification of direct message until after 1 week. The little one icon finally showed up. Then I saw you actually reach out to me, and I can't believe I missed it.
Yeah, people put their
That's
email
funny.
in, so I should technically reach out on both email and Discord, but I've just been a bit lazy to be honest, so I've been only reaching out via Discord. But yeah, I should probably do both. What is okay? DM me your email later. I see your Discord username, but I can't see I don't know what your email is, and I think the key is email. Anyways.
Oh, I think I put my email as like
Oh, I see it now.
ari.cat0626 at
Okay.
gmail.com.
I see now. Okay, I can delete you. Okay. Yeah, so you should be able to resign. Oh, there's a problem with this file. What the hell? Whatever. Not a big deal. Yeah, I mean, you can try rejoining. If it doesn't work, let me know. I'll add you manually. It's not a big deal.
Thanks, Leo.
You're welcome. Okay. Well, still a couple minutes. First time chat. Remy the gamer. Hello. Hello, hello. Yes. There's been so many signups. So that's why we're doing the extra session tomorrow. I didn't really plan on doing them on Sundays as well, but the reason I wanted to do them was because so many people are trying to get through the pipeline before school starts. I know school started this week, so it's a bit late, but so many people want to get their practice in before kind of school ramps up. So that's why we're doing the extra session this week for people. I know because I know two people asked me why are we doing it on Sundays. Are we doing it next Sunday as well? Probably not. It's a lot of stuff happening.
Okay. I think my university started like 3 weeks ago. It started on August 19th, pretty early.
Oh, I see.
It's like my third week just ended.
Oh, that's pretty early.
Yeah, I'm in Texas.
Okay, I see.
Yo, you forgot to change the title.
What the hell's the title?
What it was this week.
Frick. Okay. I can't change the title. I don't have your login. Hold up. Can I change it in here? Scene. I think you gotta change it. I don't actually have.
Okay, I do that. Street info. Found it.
Cool. Technology is hard. Technology is so hard. I don't know how to change the stream titles, guys. Okay, anyways. It's 5:01. Let's get started pretty soon. Do you have a preferred language, by the way? Let me just change a language to your preferred one.
I'll just use Python.
Python's cool? Okay, great. Okay, so I see it's 25 people already, so it's hovering around here. Let's get started. So thanks everyone for showing up to our mock interview this week. Today we have a guest with us, Leonora, and we'll be going through a sample Leetcode problem with some follow-ups depending on how it goes. Feel free to drop questions in the chat. You know, Cookie's is listening in the call, but he'll be responding to any questions in Twitch, and anything comes up, he'll address it. Okay, great. Anything you wanted to kind of say before we get started, or are you happy to get right into it?
Yeah, hey everyone, I'm ready to get started.
Okay, great. Okay, so this problem I'm going to ask you, I'm going to read it out, and you can take the notes. You can kind of, discuss what you want to talk about, and describe your approach before we get started. And if you have any questions, you have any concerns, feel free to let me know. So this question, so feel free to get rid of the starter code, by the way. So this question is called k closest points to origin. Okay. So for this problem statement, I want you to write me a function. Okay, and you're gonna take in an array of points and a integer k, and you're gonna return a list of points, a list of k points, k being the number of points that are closest to the origin. Okay, and you can return the points in any order.
Okay, so we have an array. I saw gonna have the problem description here. So we would have an array of list of points and a k, and we're gonna would you please repeat it again?
Yeah, no problem. So the input to this function is going to be a array of points, okay, and an integer k. And you're going to return a list of points, and the number and the points you return are k points. So a length k of points, and these points that you return must be the closest k points to the origin.
Okay. Closest to the origin. cool. So, like a few questions here.
Mm-hmm.
I'm kind of wondering, we're gonna have a list of points. So can I, so like for each of these points, it is in a format like the x coordinate and y coordinate, and we have two, we have two values of x and y, and they could be of any number, like positive, negative, or zero, and they might not be integers, they can also be full of numbers.
Yeah, so you can
Is that the
define.
case?
Yeah, that's the case. So a point we can define it. We can start it off as two-dimensional. So we can define it a
Mm-hmm.
point as a tuple of numbers, right? X, Y,
Uh-huh.
and they can be. You're right. They can be floating points, so they can be positive, negative, zero, or any floating point number. And the
Mm-hmm.
format that you define them in, you can define them however you want. So, for example, you might want to just define them as a list of 2 items per point, or you can define a class that you want to use, or whatever you prefer. That's all fine.
Mm. Cool. So let me like briefly write a signature here. Get k points, maybe. And we have an array called points and an integer k, and this is a placeholder. So my so can I assume that the points is always a valid array? Let's say if the points is maybe it's not none, or the points is not an array of length 0.
You can't assume their length 0, but if, for example, the length of points was 0, then k would also be 0, right? So you can guarantee that the input is valid, but I
Okay,
can't guarantee
so
you the length of the input.
if points is the array is at least of length 0, and if it's length 0, then k will be 0 as well. And if the point is let's say of length 1, will k be like a 0 and negative or something?
Yeah, so the value of k is guaranteed to be less than or equal to the length of the list of points.
Cool.
So if points
Oh,
was length 1, then k can be 0 or 1.
okay, so this is description here is k is smaller than or equal to the length of points.
Mm-hmm.
So I think my idea is we basically needs to, because we need to and when we return the return value of the length of k points, the order does not matter, right? No
Yeah, so the
matter.
order doesn't matter for return.
Order does not matter. Okay, so I think my idea is to we need to check basically each point in the points array, and we need to record its distance to the origin, and we can like sort of maintain a main heap, like to put the distance of each point, the distance from this point to the origin, push that distance to the maybe a main heap, and we're gonna maintain a heap of size k, so that all the points in this main heap would be the closest k points to the origin so far, and we're gonna keep pushing new points here if necessary, and pop new previous points out of the heap. So that's my idea.
Okay. Okay, I'm happy with that. So with the min heap approach, and can you just clarify once again? I think you mentioned this, but I want to be clear on this. Can you clarify what the key of the heap would be in this context?
Oh yeah, sure. So we're gonna so for each point we need to calculate its distance. So we get the distance from the point to the origin, and then we put this value here in the main heap. And just in case we have a tie, we can also put the sort the ID or whatever like the ID of this point to the heap as well. Maybe called ID, and we're gonna put this tuple into the main heap.
Okay, so
Does
ID in
this
this case,
sound
you're
good to
assigning
you?
an ID to every point. Is that what we're doing here?
Yeah, it's basically
Okay.
when we loop through the points this array, we can get the index of the point, so we can use that index.
Okay. Okay, cool. Yeah, I'm happy with that. And so you mentioned
Okay.
there's a tie there. So what's the situation? So if there's a tie, what happens?
And so let's see, we have 2 points. that are of the same distance, then I think also let's say we have figured out all the previous k minus 1 points and we need to figure out the last 1 point, but we have 2 points of the same distance, then I think it doesn't matter which one we choose, right, according to the description so far, or should I follow any priority?
No, it's fine right now. So as long as the output contains the k minimum, it's okay if there's any ties. That's fine. Yep.
Okay, then I think according to this table that I just mentioned, then I'll just choose the one that appears first in the array in the points this array.
Okay.
So then we can so does this algorithm sounds good to you? Before
Yep.
I actually code it up?
Yeah, let's get started with
then
that.
we can so let's first check if points is of length 0. So basically if points does not have any element, then we just return 0. Oh, just return the empty list because we need to return a list of k points, but we do not have any points, so we just return the empty list. And if point do have valid elements, then we need to loop through this points array, so we can have the index and x value, y value in the points array. And then we need to calculate distance from the point of xy to the origin, so we can get the distance is the sort of forget the isomorphism. We need to so the distance is defined as the triangle, like the distance, right? We need to use the x squared plus y squared and get the square root of that.
Okay.
I'm not sure if this is a correct method.
It's okay. Pseudocode's fine. I don't care.
Okay. I think I might need to import math here. And so this is a distance, and we need to use a heap as well. So let me import the heap pq this library. And we need to push this distance into the main heap. Oh, so before I actually push it, let me create this main heap. Now we push it into it. Heap push main heap, and we push the distance into it, and the ID for this point, which is just I. And now we check if the length of current main heap is greater than k, then we need to pop the points that is furthest from the origin.
Okay.
So we pop it from the main heap, and I think we do not need to take care of the point that will just pop up from the main heap. We can just skip it, and I think that's logic. So for each point in the points array, we get its distance, and we push it into the main heap, and we also need to maintain the main heap of size k. So if it have more than k elements, then we just pop. Oh, so I think it should be because it should be max heap.
Okay.
Yes, it should not be the main heap, because if at line 20, if I just use it, I will pop up the point that is closest to the origin. So instead of using main heap, I will use max heap. And so because main heap, we just push the original value to the heap, but if it's max heap, we need to use revert the negative value, so that the toppest one will still be this case. So the toppest one would be the one that is farthest from the So let me show an example. So if we have 3 points of distance 1, 2, 3, and instead of just pushing distance 1, 2, 3 to the hip, we need to use -3, -2, and -1. So that the toppest one would be -3, which is actually the smallest, but is the furthest one from origin.
Yeah, that's fine.
So I think this is the logic. We loop through each point in the array and then get the distance, and we push the distance and index to the max heap, and we maintain this max heap size. So after this loop, we get a main heap of size k, and we just add whatever points in this max heap to the result. So we can have a result array, and we loop, because the order does not matter, so we can just loop through the element in the max heap. So we have the distance and the index in the max heap. So one thing that I was kind of wondering, in the results array, should I just return its original x and y coordinates, or I need to return its index?
Just the original XY coordinates is fine.
Well, so I think I need to add it. Append points. And then we return the result. I think that's the code for this method, I think.
Okay. Can we walk through a sample test case?
Sure.
So we don't need to talk about the edge cases too much. I'm happy with that. Can you just make a trivial example, maybe with 2 or 3 points?
Sure. Let's say if points equals to 1. Let's say if points equals to, we have exactly original point, and we have 1, 1, and 2, 1, 3, and 2, 3. And we have k equals to maybe 2. And then we run the results here. Get k points. Point k. We need to we print result. And I think for this test case, the expected result should be 0, 0, and 1, 1, these 2 points, right?
I agree.
So let's print this too. Hopefully it could compile wrong. Oh yeah, so I think these two are the same.
Yeah, looks good to me. And can you just talk me through...
Should we try out more?
No, that's fine. I mean, in the real interview, you might, depending on the interview, you might want to do a couple more, but I'm not waste time on that. I want to walk through the time and space complexity for the current function. Can you kind of walk me through what what both variables would be?
Yep. So let's take a look at the time complexity first. So the first 3 lines doesn't actually. So the first line basically check if the point is empty or not. So which is O of 1. The max heap initializes O of 1. And the main point is we have this for loop. We check at every point in the points array. So it's like, assume that the points array have a length n. Then basically this for loop has the time complexity of O of n. And then jump into this for loop, we need to calculate the distance, which is O of 1, and we push it, and we need to push it in each iteration and pop it if necessary. And for the push and pop operation, the time complexity is O of log k. So the final time complexity for this for loop could be O of n times log k. And then after the for loop, we initialize the results array, which is O of 1, and we loop through the max heap, so which is O of k. And in each iteration, we just append the we just fetch the points at the I index and append it to the result, which is all of 1. So I think the final time complexity would be all of n log k.
Okay.
And
log
for
k.
the space,
Let me just write that down. N log k. Okay. So that's just time, and can you tell me the space?
yeah, and for the space, I think the space complexity would be k because we need to maintain a max heap of size k, and we also have an additional cost for the result array, which also have a length k. So I think the space complexity is all of k.
Okay. Can you just, so I know in this context for the space complexity, the space that you assumed was that we have our variable max heap and our result array using length k. Is there any overhead in the heap queue library, or is it safe to assume in this case that there's no extra memory being taken for processing the max heap?
Do you mean? I think we might have extra cost for initialize a maxi, but because when we initialize it, it's just an empty array. So I think no extra cost for the initialization, and we just keep pushing new items into the heap or pop it. So I think it seems fine to me.
Okay.
No extra cost.
Okay. Yeah, that's good. So in this context here, right? So we have our time and space, in log k and k. If we were to, for example, write an algorithm that was, I allow it to be, I also want it to be maybe faster, right? I want to constrain the time complexity a bit more, but in return, I let you use more space, right? Is there any sort of trade-off we can make here, or conversely, for example, I want it to be even faster, or I want to be even slower, but so let's say, for example, is there a way to make it faster and use more space? And is there a way to make it slower but use even less space? Is there any more trade-off you can make in this problem?
Yeah, so I think because the time complexity is n log k and space complexity is k, so actually use extra cost for the space if you do not consider the final result variable. So I think if I do not use extra memory for the heap, I can just calculate the results of all the points and store them in a final result, and then just sorted them using the time complexity of n log n, and then I just return the first k elements in the sorted array. So in that case, I think the time complexity would be n log n, but the space complexity would be. We still need to use a result array, but it will be of length n. But we only need the first k elements. So if you think of the extra cost, I think might be n minus k.
That's for space you're talking about?
Excuse me?
So this approach we're talking about here, you're saying that we can alternatively sort the list, right? So you're saying, so the sorting list is n log n, right? I'm happy with that. That's good, right? And then and can you repeat what you said about the space side of things? So you said this is n minus k, or?
Yeah. And so we need to calculate the distance from each point to the origin. So we still have the result array, but it will be of length n. But we only need to return the first k elements. So what we return is we return the first k elements. So in this case, this all of k, this space cost is we need to use this k space cost. So then the extra cost would be the n minus k that was skipped. So.
Okay, I understand now. So you're saying the cost of k must be incurred because it's a return. And
yes.
So the extra memory that we need is the difference between k and n. Is that the way we understand it here?
Yep.
Okay, yeah, that makes sense. Okay, so this is how you make it slower but use more memory.
Yeah, I think if we want to make it faster, we need to the time. I think the time complexity has to be all of n because we have to calculate the distance for each point. So I think the optimal time complexity would be at least all of n.
Mm-hmm.
And
what is the minimum space complexity?
and the minimum, I think no, I mean the optimal be all of n, but I haven't come up with the optimal approach yet.
Okay.
The space complexity would maybe all of one without any extra variables.
Yeah, I think the space complexity is a bit more difficult to reason in this case, right? We're thinking about there's kind of different ways to think about space complexity, right? In this context, what you've done is you've said we're only counting space that we require in addition to the return, right? So so in your first analysis for this function, you know what we should do is we should move this to a different place because it's a bit confusing. Right, so we're saying, in your original analysis, it's why does this drawing mode keep popping up? This is really annoying. We're saying that this function get k points uses k memory because we're using this max heap, right? And we're saying this is length k, right? That makes sense, right? Then in that case, then we shouldn't be counting the return because you're saying that the return is the return. We can't count that, which is okay. That's fine, right? But regardless, even if you don't count the return, it's still going to be O of k in terms of space, right?
Yes.
That makes sense. So we can follow this, chain of logic. An approach I want to talk to you about is with a function called heapify. Have you heard of heapify before?
Mm-hmm.
So heapify is a built-in function, and well, it's built into every language, but in Python it's heap.heapify, right? And the purpose of this function is to take a list of we can say pairs in this case, right? Distance to index pairs, and to create a heap in this context, right? Can you walk me through some of the pros and cons of that approach instead?
So by that approach, do you mean we just what's that heap is used for? So or just generally talk about the heapify method?
Well, we're still talking about in the context of this problem. One of the examples we can talk about in this context is the complexity of heap q.heapify is linear. Is linear with the size of the input, right?
Yeah.
Now, naively, that sounds like that might be really good because we can generate this heap in linear time. Because currently the generation for your heap, as you said, this loop here, you're seeing that this complexity is n log k, right? Now naively, to me, it seems like if we were able to leverage heap q.heapify, we can process this in O of n time. Can you walk me through that chain of logic and see if it's actually better or not?
I think so. If we want to use heapify, we basically need to calculate the distances of length n, which contains all the distance for the points, and then we just use heap q.heapify in distances, and then we return the first k in this array. And we want to talk about the pros and cons of this approach.
Yeah, we want to talk a bit about the pros and cons, but also want to talk about, is this actually going to be an improvement, right? The question here, right, is that heapify can create a heap in linear time, right? So this is linear time. This is O of n. Well, this is O of length of distance, which is O of n, right? So I'm giving that to you. That's O of n. Now, is that actually going to improve the time or space complexity of this algorithm?
I think in terms of space complexity, it will be because the heap will be of length k, all of length n, so the space complexity will actually increase because we know k is smaller than or equal to the n. So if we use this one, then space complexity would increase from k to n. But in terms of time complexity, I think it seems that we do have a improvement in time in terms of time complexity from n log k to n.
Can you walk me through that reasoning? So why is it that now we don't need to incur the log k component?
Because I think so heapify is basically give a list, and no matter it's sorted or not, we would make it into a heap following the pattern of the main heap, and then we get the first k elements with so according to heap's properties, it will be the k smallest items in the heap. And because the heapify it does not, if we want to build a heap, we can like following the pattern of push each new element to the heap, or you can use the heapify. You have a sift down and sift up that approach. So in that approach, we have the time complexity of building a heap is O of n. So we have two different types, two different methods to build a heap. So according to Python's building method of heapify, the time complexity will be O of n. So then it means this basically means that for us to get the sorted part of the distances array, with the time complexity would be O of n.
Yeah.
So I think that's improvement.
So maybe you can sketch out a little pseudocode here, right? So let me just start a second function. Okay. Def get k points to, right? So it's the same thing, and I'm saying so we have, so I'm gonna check the edge cases. So we say we have a heap, right? And we do stuff, blah blah blah. So heap equals get heap, get distances, we don't care, right? And then we say heap q dot heapify, right? So this is what you're saying, right? And now you're saying return something, right? This is what you're saying here, okay? This is O of n, right? This is good, right? And then what? Because that's not the end of the algorithm.
Yeah, I think we might need to do some data processing of the heap. We only need the first k elements in this heap.
What can you be precise there? What does first k elements in the heap mean? Because the type of heap is a list. This is a list.
Yeah.
Right?
Yeah.
And I want to clarify that the first k in a list is not necessarily the first thing as the first k in a heap.
Oh, I think if we have a tree, see, if we have the heap, imagine we have the heap tree, and it's like a binary tree. It is guaranteed that the and we have, let's say we have a heap of height 3, and we have level 1, level 2, and level 3. It's guaranteed that all the elements in the level 3 are greater than the elements in the level 2, and elements in the level 2 are guaranteed to be greater than the elements in the level 1, or at least the same. So in that case, if k happens to be the boundary between different levels, let's say the first level and the second level, then by fetching the first k elements in the heap, we would actually get the smallest k elements in the heap. But if k falls within the it's not the boundary. So let's say if k is somewhere else in k. So let's say assume for the first 2 levels we have 3 elements, and the
by the
first
way,
level.
If it's easier, we can open the drawing window and you can draw it out if it's easier for you. I'm offering that's an option. Up to you.
Okay. So let's see, we have this heap. Oh, can you see my drawing?
Yeah, I can see it. Yeah.
So let's see, this is 1, and this is 2, and this is 3. So let's say the number of elements in the first 2 levels is, let's say is x, and the number of elements, so in total, 1 plus 2 is x, and the 3 number of elements in the third level is y, and
Okay.
we have k. So if k is smaller than x, so if k is exactly x, so these two are the same, then by fetching the heap, the first k elements, we would actually get the k smallest one in the heap. But if k is greater than x is smaller than y, then we may not, by using this slicing, we might not be able to get the k smallest. So we will be able to get the x smallest, but for the elements like larger than x and smaller than k is not guaranteed. We may not guarantee to get the k smallest.
Yeah. So the key here I want to talk about, right, is
Mm-hmm.
how in this case we're talking about is a heap, right? If you are taking a slice like at exactly a boundary,
Mm-hmm.
you can guarantee that at the boundary and above, so you have a max heap, right? So at the boundary above are the biggest
Mm-hmm.
elements, right?
Yeah.
But you cannot take a slice in between levels,
Yeah.
right? Because there's no relation between the
Mm.
elements on both sides of the slice.
Yeah.
Okay.
So I think in this case, we might need to use some math tricks as if k. So for at each level, the number of elements could be like 2 to the power of 0, 2 to the power of 1, 2 to the power of 3 or 4. So
Mm-hmm.
we might need to check the relationship between k and 2 to the power of what
Okay.
some
Yeah,
can
I
do
like.
that check, and then when we do some extra check for the elements remaining in the last level.
Okay, I like that, right? So we're talking in this context, right? If k is essentially a power of two, right? If k is a
Mm-hmm.
power of two, then we can slice the backing list, right? We can guarantee that it's correct, right?
It's like the sum of.
Yeah. It's the sum. Sorry, if it's a sum of a power of two,
Uh-huh.
then we can guarantee that it's going to be falling between levels, right? So,
Mm-hmm.
that's good. Now, if it's not, so we're saying now if it's not that, which most numbers wouldn't be that, right? If it's
Mm-hmm.
not that, then we have to do some more math.
Yeah.
Okay. Can you tell me just if you have intuition on this one? I don't want to spend too much time on this, but it's an intuition question. So
Mm-hmm.
like okay, so let's say you cannot assume k, so therefore you have to assume to do math. Okay, so the math in this case, I'm not going to go through the math, but can you tell me the complexity of this math? In other words, if we were to do this math, what would be the time complexity of a solution for this kind of problem?
So if the processing for the remaining elements in the last level, after we removing the first, let's say the sum of power 2 is m. After removing the first m elements, we can do maybe like the most straightforward way, we can just maybe sort the remaining part of a heap again, or we can just use the heapify again to make it I think we'll make it a heap, and then we can just pop out the remaining number of elements. So
Okay.
it kind of depends, like maybe um, um, so if we have the n is still the original length of the heap is still n, so maybe n minus m, it should be k. So
You can do undo here. Yeah, there you go.
yeah, so we have k minus m elements remaining to determine, and we can maybe know this is the number of elements needed and times the size of the heap right now is n minus m. Every time of the top time complexity will be log. So this is the time complexity. So we need to do the pop operation k minus n times, and for each of this operation, the time complexity is log n minus m. And we might need to do heapify again, like if the remaining parts does not form a valid heap.
Yeah, I like that. That's what you said is correct. To be more precise, we don't. So we can have more levels here, right? And remember, the size of every level is it's proportional to in a sense, right? The bottommost level will be n minus n divided by 2, roughly, right? But if we, for example, if our k is relatively small and we can end on a level that's not the bottom level, we only need to consider the values within this level, right? Because if our divider is in a level, there's no way we have a value from underneath it, right? That's the definition here, right?
Yep.
So in a sense, you can actually tighten this
yeah.
constraint a bit more, right?
Yeah,
because we only need to the size of this should be the size of the level,
Yeah.
right? But okay, no, that's fine. I like the math we've done here. So this is totally fine. We've gone really deep into heap complexity here, so that's enough. That's enough thinking about that for now. Okay. Is everything clear so far about the heat complexity part? Okay, great. Let's go back to the code for a bit. Okay, so let me just remind myself, what the hell was I talking about? So that was good. I like that. And the complexity is fine. So we got really detailed. I'm not gonna ask about the overall complexity. I want to ask a little bit of a couple more follow-ups about the situation we have here. Okay, so I'm happy with this. So now from now on, let's just consider your original approach. This was just an exploration, so we don't need to worry about that. Okay, so one thing that we've given here, right? So I've let you assume that the points are two-dimensional. Okay. Now let me say that the points have d dimensions. Okay. So if the points are d-dimensional, can you reevaluate the time and space complexity? And tell me what we need to change in the code.
Yeah, so because we know, I assume we only have 2 dimensions, so the time complexity is just, we do the math is all of 1. But if s is of d dimension, we need to do the square of each dimension and get its sum and get the square root of that, right? And that's for the calculation of the distance. And so instead of using the original line 22, it might be the mass dot square root on the sum of each dimension. For x in e or something. So then the time complexity of the calculation would be all of d, I think.
Okay.
Because the calculation part, the remaining will be the same.
Yeah, that's good. And what's the change in overall complexity going to be?
So actually the original one, to be more specific, is n times 2 plus log k, and now it will change from 2 to d.
Okay, d for the number of dimensions, and
where's
the log k
the number of dimensions. Log k is still for the heap operations.
Okay, so this is this log k originally one.
Oh yeah, or like this one.
Okay, yeah. Okay, and does the space change?
I think space will still be the same because we do not introduce any extra, explicitly introduce any extra variables. And let's see, we have this one x is all of 1. We just loop using x to loop all the d dimensions and can get the sum and do the math operation. So I think the space complexity will be the same.
Okay, so even if we have a million dimensions, the space complexity will still be O of k in this case. Okay.
Yeah.
And one more follow-up here on this. So this is not related to dimensions anymore. We can go back to assuming there's only 2 dimensions. That doesn't matter. Right now let's say I want to convert this problem to a online problem. Okay. Are you familiar with online algorithms?
I think I kind of learned the online algorithms in the class, but my memories are not fresh.
Okay, no worries. Let's go through that. So let me just write the details over here. Oh, Python. Can I do this? Oh no, it's this thing. Okay, so this is another follow up. This will probably be the last follow up. Look at the time, right? So I want to go through how we would modify this algorithm to be an online algorithm. Okay, so here's roughly the framework for what that means, right? So an algorithm is an online algorithm if we can change the backing data as data is being processed. Okay. So what that means for example, to get k points is we can get k points, right? We can query our data system for k points, k closest points to the origin, but we can also add or remove points along the way. Okay, so think about if you were making an API or some class, right? We can have a method which I have right now, right? Get k points, okay, but it wouldn't take a points array. It would just have k. Okay, and in addition to this function, we might have a function such as add point that takes a point, right? We might have a function remove point that takes a point, right? Can you kind of see where I'm going with this? We have
Oh, yes.
so we can have, for example, some class, doesn't matter,
Got it.
right? We can have get k points, right? And we have k, right? Do that, and then we have def add point, right? And then we have def right? So this is a
Okay.
framework I'm talking about here. If you were to have this sort of framework, and you had, so you still have your get k points, can you tell me, would anything kind of change in this context? So for example, would you still be using a heap? Would you handle the heap differently? What sort of considerations would you make to adapt your algorithm to be an online algorithm?
Sure. So can I think that the flow of the problem would be we have three kind of operations: get, add, and remove, and we just have a flow of operations. It might be get, might be add, might be remove. And by get, we just return the k closest one. By add, we just introduce a new point, and remove, we just remove the current point,
Yep.
any current point in the points array. Okay, so I think in this case, a few more logic needed is we still need the points. We need to know the size of we need to know the number of points we have, and just as a placeholder. And when we use get, we need to first check if we have enough k points in the. Let's say we have current points. This is a list, and we have a size. Then we can just use the length of current points. And then for the get operation, we first need to check if k is bigger than self.size. In this case, then we can use that init.
Yeah, this could just be pseudocode. I'm not too concerned about the details here.
So if k is greater than the size, then we just so then this case, what should we do then? So we just return all the points we have.
Sure. Anything reasonable is fine. That's fine.
Yeah. So then we just basically return all the points we have at the. Otherwise, then we just follow the same follow the old get k points.
Okay.
Okay, and it's old logic. And for the add, then we just basically we need to calculate the distance first, and then we need to add this point to the self.points. points. So we can rename it as register the point in self.points. points. And we need to add the distance, and also we need to register its distance. We can have a heap here, self.max heap, and we need to register this distance in the max heap. And then for the remove part, we just we still have this x value and y value, and then we can get its distance and then we need to get the distance of the point, and then we need to remove the distance from the point, from the max heap. And one thing I can think of is we might have 2 points of the same distance, and but we only want to remove the distance of exactly of this point. So we basically need to check when we remove the distance from the heap. We need to check whether this is exactly the point we want. If not, we might need to push the distance and the point back to the heap, max heap. And then in this case, so it's not a logic here. So because we maintain the heap size in the remove and add, then then in this else block, we can just return the points in the max heap. So the first k points in the max heap.
That's essentially the original algorithm you're saying. This one. Okay.
So it's no, it's not like the because the old logic in the old get k points is sort of get split in the add and remove.
Okay.
I think because we might in the add method we need to add the new point to the self-dot points, and we need to add its distance in the max heap. But we do not need to maintain the size of max heap, because if let's say we have exactly k points right now, and then we remove it, and so let's say the previous the k points would be like the res is the original value for the first k point, the k smallest closest one, and we remove it, and now the one of the k closest gets removed, then the k plus 1's closest will get jump to the result array. So I think we might do not need to maintain the max heap size.
Yeah, we don't need this. Yeah, I think the size is redundant, but we still need to calculate of the given points what is needed in that context. A question I wanted to ask in this context, right, is one of the benefits that we originally discussed for using a heap is to essentially maintain the heap invariant, right? The heap invariant is we know that some point is the closest or maximum or minimum or whatever we're talking about, right? One thing I want to jump at is with the remove method. Okay, so in the remove method, we're given a point, or you can begin anything you want, right? This will decrease the size of points and the size of max heap, right? How does that? You know what I mean? Like when you say remove from the heap, what is the complexity there? That's not trivial, right?
Yeah, we think we can maintain a field called removed, which is basically the asset, and we need to, when we have a point that needs to be removed, we need to first calculate distance, and we need to add this self dot removed, add this distance and the point to the set, and that's it. So then before we use the get k points, we need to check each point in the max heap, and we need to make sure it's not in self.removed. If it's, then we just skip this one and check the next one.
Okay, I got it.
So it's not a hard delete. Hard remove is like soft remove.
And in what context would you do a hard delete, right? So for example, if you can imagine someone at the bottom here, they call their class c equals c, and then they add a lot, right? So they add some stuff, doesn't matter, and then they remove a whole bunch of stuff, right? And so I know I do this like a lot of times.
If we actually want to remove it, then we might need to use the time complexity with the O of n to remove an element from the array. So then in this case, we need to do hard remove. Then we need to remove the points from self-dot points, and we also need to because the heap I think for heap we only have push and pop operations when we might need to like keep popping from the max heap until we met the point that we want to remove, and then we pop exactly that point out. Then we keep pushing the previous points back to the max heap.
That's one way to do it. That's a bit difficult sometimes, because if your set of removed is very large, right, then it's going to be that might be a bit more difficult. But that's okay. Let's pause here. Do you have something to say? Go ahead.
Just remove, instead of trying to use a heap, we can just treat it as a list and use time complexity of all of n to remove the point from the list, and then after removing, we just turn that list to the heap again.
That's the more common way to do it. Okay, let's pause here. And let's quickly talk about things. We got about 6 minutes. So let's go over just quickly at a high level, how we feel about this, and some kind of comments about some follow-ups. First of all, there's really not much to say about the base problem. This is a medium level difficulty one, and you might have seen it before, so that's not the interesting part, right? Getting good clarifications about the question statements, that was very, very strong. I think that was a very good part. That's something which, even if you know the question, right, if you've seen the question before, it's still always good to go through and ask for clarifications about the input, about the output, types, constraints if they apply, right? Because for example, they might be asking variation or something else that they want to test about. So it's always good to just clarify that. So that was very well done. Approach to the min heap or max heap or whatever you want to call it, that was very good as well. One thing I will say that might save you a bit of time for questions that you might not be as familiar with is to write a trivial test case. Like, not too trivial, like write a test case which is like the one you wrote, which is like, four items, right? And I think the reason that's the case is because you're gonna need that anyways, right? Like, you're gonna need to have a test case anyways. You might as well write that before you start coding, so that you can use your, you can solve it manually before, and then just align with the interviewer, make sure that this is what they expect, right? Because if you do that anyways, might as well do it at the front. Okay, that's good. Implementation was very fast. I didn't say there, that was reasonable. Time complexity analysis, this is obviously, I push you a lot on the follow-up there. This is obviously a strong suit of yours, right? This is very, very good analysis on that part. I will say, in general, this is kind of like a meta tip, so you don't have to always do this, but if you know that you're going through a problem very quickly and that there's a lot of time, I would recommend writing the time complexity of every single line of code beside it. So for example, you were saying it, so you're saying, this is O1, this is 1, right? Initialization is 1, right? This is in. Oh, that's autocorrect. This is 1. And the reason I say this is because, right, this makes it very easy in the future if you were to make modifications. So for example, you modified this line, right? You can say, this is D. And this is very trivially n times D. Right. So this is an example of something which just for your clarity's sake, just write the complexity of every line beside it, and you know how to calculate, right? If it's nested, you multiply. If it's same level, you just add them. All right. So this is something which I think is a little tip, because in questions where the interviewer is going to ask you to modify a lot of your code, that will save you a lot of time for analysis.
Yeah, makes sense.
Okay. Cool. And then, so that's that heap queue. What is that right here? Understand check. Okay, yeah. The heap queue heapify method, that's sort of like one of the key methods to kind of know, right? I don't know if you wasn't aware of it, or you forgot about that fact that it runs in linear time. If you're ever in a situation where you see a problem is using heaps, right? The first thing you should actually ask yourself is, am I trading time or space? Because the only reason you would ever use a heap over a sorted list, the sorted list or sorted list, aka binary search tree, right? The only reason you would ever use a heap is because there are situations in a heap where you can save memory, or sometimes save a bit of time, right? Because it's less strict than a sorted list. So if you're using a heap, the first thing you should think to yourself is, am I saving space or am I saving time? Because if you're saving time, then you want to use heapify. Or not always. Like just think about it, right? If you're trying to save time, heapify is your friend. If you're trying to save space, then you want to do this k-length heap, right? So there's a bit of nuance and trade-off there that you should be asking yourself before you start coding. And if there's ambiguity there, you should ask the interviewer, hey, should we optimize for time or space in this solution, right? So with a heap, you're given that opportunity a lot easier, right? If you look at
Got
the
it.
online algorithm here, the reason I ask you this is because I know you didn't think about if you should use a heap or not. Because I know for this problem, it's very obvious to use a heap. But in the online algorithm, um, if you think about it, there's no reason to use a heap if you can just use a sorted list, right? If you just instead maintain a sorted list of points sorted by the distance, add and remove are always log in. Sometimes remove will be in, okay, because it's memoized, right? Because it's a binary search tree. This is a binary search tree, right? Add and remove are
Yeah.
log in. Get k is a level order traversal. That's gonna be O of k, right? So this is an example of an interviewer catching you getting too locked up in the heap world, when in reality, if you step away from it
Yeah.
a bit, that's actually suboptimal. Okay, will they dock you points for that? Maybe only a little bit, right? But just keep in mind that when you start getting asked follow-up questions, you have to start being flexible with the approach, right? It's not always going to be a
Uh-huh.
heap. So small comment about that.
Got it.
The
Thanks,
drawing was
Leo.
pretty good. Drawing was very good. I mean, it's a bit messy. It doesn't really matter. I think the analysis here was very strong. A key thing here, which had to be pointed out, right, was if the partition K is not between levels, there's some complexity there, right? So just keep in mind, right? This is another nuance with heaps, right? The nuance of heaps here being that, um, you know, items within a
Yeah.
level are not sorted. So small detail there.
Yeah.
Okay,
Thanks, Leo.
that's all on my side. Any questions on your side before we wrap it up here?
No, I think all good. Thank you so much, Leo.
Okay, great. Then that should be all. Thank you everyone for watching. I think we're going to transition right into the resume review. So thank you very much, Leonora.
Thanks, Leo. Bye,
Bye
everyone.
bye.
Bye.
Okay, Cookie. Should I end the stream on my side and then you can start it up again?
Do you just want to just go to the Figma, or are you leaving?